Again, if I could have your attention. No, I said no, I didn't have it. Sorry, I looked at the cover. All right, so in our last section, we were talking about solving equations. Today we are going to talk about solving inequalities. Very, very similar to equations. All the steps, all the process is the same. You just end up with greater than or less than or whatever instead of equal to. So as usual, we are going to start with a little problem for you guys to do with your partners. So on a piece of paper that you will eventually do your homework assignment on and turn into me, will you solve this problem? It says you want to download some new songs on your MP3 player. Each song will use about 4.3 megabytes of space. The amount of stored space on your MP3 player is shown at right. So if you can't read this, it says there's 7.8 gigabytes free out of 19.5 total gigabytes. At most, how many songs can you download? And we have a little conversion going here. 1 gigabyte equals 1,000 megabytes. Okay, so with your group at your table, will you answer the question? At most, how many songs can you download? Okay. Okay. Anybody want to share their solution? Anybody in the 1800 whatever answer group would like to say how you? Yeah, here.
Okay. So there's 7.8 gigabytes free.
Oh, so time out. That's where you went wrong, and Ash, you went wrong, and you guys went wrong, and I read that incorrectly too. This is how many gigabytes are free. That's not how many have been used out of this total. Does that make sense? So you guys start by subtracting this and this. Okay, that's kind of what I was thinking too. But this is how many you have left. So will you redo your calculations and use 7.8 instead of whatever that was, 11.7? Okay, keep going.
And so since it's gigabytes, you'll have to get it to megabytes.
Okay, so 7.8 gigabytes turns out to be
7,800.
7,800 megabytes because you multiplied by 1,000. Okay, so you have 7,800 megabytes free. What'd you do from there?
Divided by 4.3 megabytes.
Okay, divided by 4.3. And what did you get?
1,800. Well, yeah, 1,813.
1,813.9. Okay. Did anybody in here do this exact calculation and then write down 1,814? Okay, good. How come we can't round up in this situation?
Because that's more than the
Right, because then that would be more than the amount of room we have, so we don't quite have enough room to fit this last song. Okay, but no big deal. We all have Spotify now anyway, so we don't need to download music anymore. Okay, good. So that's the idea of the inequality. You could download up to this many songs, but you could not download more than that. So X could be less than or equal to 1,813 songs. Okay? When you guys redid it with the 7.8, did you get that same answer? Yeah. Okay. All right, good deal. Okay, so that's an example of the inequality. And of course, one of the most fun things to do with inequalities, I mean, there are so many fun things to do with them. It's hard to pick out which one is the most fun. But one of them is graphing them on a number line, okay? And so some students get a little bit confused about which direction they should draw the arrow. Some students get a little bit confused about whether it should be an open circle or a closed dot. This encompasses all of that information. I always say that if you solve the inequality and you end up with a variable on the left, which is what you normally do, this is sort of like an arrowhead that's pointing the direction that the line should go, okay? So if you end up with x is greater than 4, it's pointing to the right. so the arrow is going to go to the right. Whereas if you end up with x is less than 4, then the arrow is pointing in this to the left, so the arrow that you draw on your number line goes to the left as well, okay? And then the open circle, if you don't remember, means that it cannot equal that number. It can get as close as you possibly want to it, but it can't equal it. And then the closed dot means that it equals it as well, okay? So that's sort of a cheat sheet if you don't remember how all that fun stuff goes, okay? All right, so for example, if I were to write an inequality that represented this sentence, 5 fewer than a number is at least 12. First of all, 5 fewer than a number is what? N minus 5, whatever the number is that you start with, whether it's an X or an N or a W or whatever, that is at least 12. Can it be 12?
Yes.
Yes. Can it be less than 12?
No.
No. Can it be greater than 12?
C.
Yes. So at least means greater than or equal to. Okay? At least means greater than or equal to. All right? Okay, on that same piece of paper that you just solved the starting out problem, will you do this? What inequality represents the sentence? The quotient of a number in 3 is no more than 15. Okay? The quotient of a number in 3 is no more than 15. Okay, so it looks like we got everybody in the end. Quotient is a fancy word for divide. Okay? And then no more than 15 means it has to be less than or equal to 15. Can't be any bigger than that. All right? Okay, the thing that's different about the main difference between inequalities and equations is usually the equations that we work with have only 1 or maybe 2 solutions. Inequalities have an infinite number of solutions, because if you want a number that's no more than 15, then that's 15, 14, 13, 12, 11, 10, 9, 8, all of those, plus 14.5 and 14.2 and all the decimals in there, okay? Also remember that when you multiply or divide by a negative number, you have to switch the inequality. Do you guys know why that is? Do you want to see a quick?
Yes,
Is that something that you just always just told and you just do?
Yeah.
Okay, so let's say that I have negative 3x is greater than 9. If we do this the fast and easy way, we divide both sides by negative 3. And then those cancel, and then x, switch the inequality because of the negative. 9 divided by negative 3 is negative 3, right? So that's the sort of brainwashing way to do it. But what we're really doing here when I start out with negative 3x is greater than 9 is I am adding 3x to both sides to start with. So these cancel and I get 0 is greater than 9 plus 3x. And then I subtract 9 from both sides, so these cancel, and I get negative 9 is greater than 3x. And do you see what happened to my variable when I added it to both sides? Now it ends up on the small side of the inequality. And then if I divide both sides by 3, since I'm not dividing by a negative, I don't flip the inequality sign, okay? So that's all that's happening here is you're just saving a step. Instead of switching those around first and then dividing, you just remember that if you multiply or divide by a negative, you have to do that thing, okay? All right, and then all the properties that we study, or didn't study, but we kind of wrote down for solving equations also work for inequalities. If you add the same thing both sides, the inequality will still hold true, subtract, etc., etc., okay? Okay, but again, we're going to get a little bit trickier than that because this is advanced algebra. So let's take a look at negative 3 times the quantity 2x minus 5 plus 1 greater than or equal to 4. And let's not ask Siri what the answer is. Let's figure it out all by ourselves, okay? What do I do first to solve this inequality? Distribute the negative 3. So negative 3 times 2x is negative 6x. Negative 3 times negative 5 is plus 15. I still have the plus 1, and I want that to be greater than or equal to 4. So far, so good? Okay, what's my next step? What's that? Okay, what can I simplify? Page 15 and 1 make 16. All right, so now I have combined all my like terms on the left and the right. Destiny, what now?
You subtract 16.
Okay, subtract 16 from both sides because already all of the variables are on the left, so I might as well get all the numbers on the right. So these will cancel. Negative 6x is greater than or equal to negative 12. And then my final step is, sir?
Is it divide by negative 6?
It is divide by negative 6, and since you said divide by negative 6, what do I have to do with the inequality symbol? Flip it around. So instead of being greater than or equal to, it's going to be less than or equal to negative 2 divided by negative 6, which is 2. Okay? So that's the step-by-step, and like I said at the top of the lesson, that's basically exactly the same as when you're solving equations. Now we're going to throw on this graph, okay? I don't know who you have had before as math teachers. I do know for sure they've been better teachers than me, and so I apologize that you are stuck with this. A lot of times, math teachers get really into the whole like number line thing. We're going to go 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, and make it all neat and stuff. When you do these, I just need to know where 0 is. I need to know where the number that you're interested in is, and then are we going to the left or the right?
We're going to the left.
We're going to the left because I want numbers that are smaller than 2. And is this going to be an open circle or a closed circle?
Closed.
That's closed. And so this right here is a pretty acceptable number line graph for me. Okay? I just want 0, and then I want the number that we're interested in, so you understand if it's positive or negative or whatever, and then draw it in from there. But you don't have to put in a bunch of different tick marks. Okay? All right. Once again, on that same sheet of paper, will you solve this inequality and then graph the solution? Okay, looks like most of you came up with the correct answer, which is x is less than or equal to negative 8. And then when you graph this, whoops, when you graph this, you got a 0, you got a negative 8. We're less than or equal to that, so it's a closed dot, and then it goes to the left, right? Okay, wouldn't be a good day of algebra if we didn't have a chance to do a word problem or two. So let's make sure we get one of these in right now. That's what I'm talking about. So the movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as you want, or you can pay just $15 a month and then pay $1.50 to rent each movies. How many movies must you rent in a month for the first plan to cost less than the second plan? So what is a equation that we could use for the first plan? This one, $36 a month. 36. That's going to cost you $36. Okay. What is an equation for the second one where you pay $15 a month and then tack onto that $1.50 for every rental? Okay, 15 plus 1.5, you're going to go with n for movies. And who do we want to be less than the other one? How many movies must you rent in a month for the first plan to cost less than the other one? Okay, so that is our inequality. How do I solve this? 2 quick steps. Subtract 15 from both sides. So 36 take away 15 is 21. These cancel, 1.5 in, and then I heard it already, what? Divide by 1.5. Anybody have 21 divided by 1.5 right off the top of their head? 10.25. Destiny? 14 even?
Yeah.
Okay. All right. So 14 has to be, the number of movies has to be greater than 14, okay? What would be true about the 2 plans if you rented exactly 14 movies?
It would cost the same.
It appears that they would be equal, yeah. So if you rent more than 14 movies, then you're going to pay more than $36 with the second plan, so that makes the first one cheaper, okay? All right. Then, just like we talked about when we were solving equations, sometimes funny things happen with inequalities as well. The only difference is that this time, when you're solving equations, if you get something like 5 equals 2, then you know that's no solution, right? But for an inequality, that can actually come up with some correct answers because it might be 5 is greater than 2, which is in fact true. So you have to be a little bit more careful here. So what's our first step solving this? Distribute. So negative 2 times 3x is negative 6x. Negative 2 times 1 is negative 2. And that you want to be greater than negative 6x plus 7. Okay? Right, plug in any number, and is it true or false, or always true, or sometimes true, or any idea? I want to go a step further on this one. A lot of you can see the end of the story, but let's make sure. I'm going to add 6x to both sides, and then what most of you have noticed is that since there's a negative 6 on both sides, those cancel. So that leaves me with negative 2 that is a poor greater than sign. There we go. That's not much better. Negative 2 is greater than 7. Okay? Is that a true statement? No. Negative 2, how often is negative 2 greater than 7? Never. So since negative 2 is never greater than 7, that means negative 2 times 3x plus 1 is never greater than negative 6x plus 7. Okay? But do you see the difference if I flip this inequality, and if in the end I got negative 2 is less than 7? Is this true? Yeah, this is always true. And so if this was what we ended up with, then the answer would be always. So it's a little bit trickier than with the equations where you know if you get 2 different numbers, the answer is no solution. With an inequality, you have to pay attention to which direction the inequality symbol is going, because depending on that, it might never be true, or it might always be true, okay? Let's try another one of these. First step would be what? Distribute. We're practicing that a lot, so we got 10x minus 15 minus 7x is less than or equal to 3x plus 8. And then... And then, what?
Plug in.
No, we're not plugging in anything. Simplify. How do I simplify? What like terms can I combine?
Oh, we're negative.
Right, the 10x and the negative 7x will simplify to be 3x minus 15. And then this stays as 3x plus 8. Since I have a 3x on both sides, what can I do with those? Just get rid of them. Take those out. So that leaves me with negative 15 is less than or equal to 8. Sometimes always or never true.
Sometimes.
Sometimes negative 15 is less than or equal to 8?
Always.
Always. Negative 15 is always less than or equal to 8. So that one is always going to be true. So again, different numbers, but it depends on which way the inequality is going. That determines our answer. All right. So again, try this one by your lonesome, and I'll come around and see if you need any help. Okay, here's a room pretty good shape. Walking around the room, most people are distributed on both sides. And then you notice that there's 8 x's here and 8 x's there, so those can cancel out. So you get negative 12 is less than 8, which is always true. Okay? Good deal. All right, and then finally, because this is advanced algebra, why stop with only one inequality when you could just as easily do 2? If you have 2 inequalities in the same expression, that's called a compound inequality, in the same way that if you hurt yourself and break a bone and there's more than one break, they call it a compound fracture. Okay? That means we've got more than one thing going on at the same time. Okay? So for example, for this one, we want 7 to be less than 2x plus 1, and at the same time, we need 3x to be less than or equal to 18. Okay? So this is just a sort of 2 for the price of 1 deal. I'm going to just think of these as 2 separate problems, solve them each independently, and then I'm going to look at the graph and see what happens then. What do I do to solve this? Subtract 1 from both sides, so that is 6 is less than 2x. And then divide by 2. Do you guys mind, can I flip this around so the x comes first?
Sure.
Okay, so that means that x has to be greater than 3. Okay? How about this one right here to solve that one step? Yeah, you can see that that's going to be 6 because I divide both sides by 3. So that means that x is less than or equal to 6. Okay? Now, this is an and problem. And in an and situation, you need both things to be true at the same time. So for example, Seth is going to marry a woman who is rich and beautiful. Okay? So Jennifer Aniston, that's a thumbs up. Okay? Sorry, a little bit, that's in my generation. What? Selena Gomez. Selena Gomez is a win, both rich and beautiful. But I don't want to say anything inappropriate. I don't know, the gals here in this class, certainly probably all beautiful, but maybe not necessarily rich. I don't know, okay? But he's going for both. So, same thing is true with this inequality. I want these two things to hold true at the same time. I need x to be greater than 3, but I also need it to be less than or equal to 6, okay? So, these numbers over here are no good. They are greater than 3, so that fits this one, but they're not less than or equal to 6. Same deal over here. These on this side, am I in trouble?
No, I was saying since they're facing each other.
Okay, perfect. So he's getting right to the chase here. Since the arrows are pointing to each other, then that means I need to just be inside this small window right here, okay? So if you're looking for rich and beautiful, then there's a more narrow window than if you want just rich or just beautiful, okay? Has to be in between there, all right? Okay, so you guys on your own, 5 is less than or equal to 3x minus 1, and 2x is less than 12. Give that a try on your own, and the key is going to be the graph. Okay, so if you solve this one, you get that x has to be greater than or equal to 2. If you solve this one, you get x has to be less than 6. And then if you put those on a number line, you got your 2, you got your 6. This is a closed circle, that's an open circle, anything in between. Okay, the other option that we could have is we could be in an or situation, and then we're not being picky, okay? So that would be more like Dakota. He's hoping for either rich or beautiful. The chances of getting both, not very good. Okay? So in this case, we don't have to have, he's not shallow. He's not shallow. He's pretty shallow. He's just looking for someone, he's just looking for true love. Not like sex. Okay? Yeah, exactly. Okay, so in an or situation, if I take these and solve this, I have to subtract 7 from both sides here. The 7's cancel, and k is greater than or equal to -1. Or on this side, if I subtract 8 from both sides, I get k is less than -5. Okay, so now when I make my graph, Caden, you pointed this out before. Now the arrows are no, they're still pointing at each other. I was going to say, so never mind. This one I need to be greater than or equal to -1. So let's throw a -1 right here, close circle, and then that's going to go off that direction. And then over here, I have a -5, an open circle, and that's going to go off to the left, okay? So as long as we don't pick a number in between -5 and -1, we're going to be okay, because it's either going to make this one true or this one true, but I don't have to have both of them true at the same time. What would be the answer here if instead of saying or, this had said and?
Doesn't work.
No, I still do the math the same way, and I still end up with these two inequalities, but instead of saying or, it says and. I make my graph, what do you see?
Oh, because it can be either way.
But it can't be. If it's and, it has to be both at the same time. What's that? It would be not possible, yes, this would be no solution, okay, because they don't overlap. They're pointing in separate directions. Let's go back to this one here. What if this one had been or? So this is going this way and this is going that way. What would the answer be then? Yes?
Not possible.
No, it would be possible.
But it would be just over.
What would be true here if I needed just either one was fine? I either needed a number, it could be greater than or equal to 2 or less than 6, I don't care, as long as it's one or the other.
And just be in between those two numbers.
No, because I could pick 7. Because 7 isn't less than 6, but that's okay because it is greater than or equal to 2, right? So now all these numbers come back into play. Or I could pick these down here, I could pick 0. 0 is not greater than 2, but it is less than 6, so it qualifies there. So what would the solution be then? Yeah, infinite, all real numbers. Any number that you pick would make that work, okay? So, funky things happen with inequality, all right? Okay, a few problems for you guys to work on your own.